This video will go over Chapter 4 problems 13 and 14. I have already sent out to you, you might say, the hard copy of the solution, but I just wanted to make a couple of comments in regard to this particular problem, or problems 13 and 14. Keep in mind, this is simple linear regression, and the reason I refer to it as simple is that we're just dealing with one predictor variable or independent variable. Now, from the problem, what we want to be able to ascertain, or what we want to be able to estimate, forecast, is if someone takes a test, and we'll say in this particular problem the first test, and we're going to record the grade, can we use that to forecast or estimate what the final grade will be? So therefore we have, of course, two variables. The first grade is our independent variable, or our predictor variable. The final grade happens to be what we're trying to forecast, and that becomes our dependent variable. Once again, first grade is our predictor variable, independent variable. Final grade is our dependent variable. So here we have on the Excel spreadsheet, we have the data. So let me go to the summary sheet, and if you recall the previous video that I have up, it was simply an illustration, if you had not already done so in Excel, to add the data pack. Once again, this is just for PC users. Mac users, I'm sorry, but Microsoft does not provide a data pack in the Office suite for Mac. But anyway, that's neither here nor there. That will be up for another discussion. However, this will be for PCs that I had that video about being able to add in the data pack for the regression. So you have the data here, and let me just come back in here and show the summary sheet. This is our summary output, and in a summary output in regard to Excel, we have really three areas. We have what's referred to as regression statistics, we have the analysis of variance, and then the third one down here will give us will help us to identify what the equation is, and also I'll go through the p-value. And the p-value is critical, just more from the standpoint it will tell us if the relationship between our dependent variable and our predictive variable happens to be significant. Significant from the sense that we can utilize the variables. We can utilize the predictor variable to forecast whatever that dependent variable happens to be. So in this particular case, we can come back up here to regression statistics. You can see R square is 84.7%. And that's the coefficient of determination. From my standpoint, when I do analytical endeavors, I always focus in on the coefficient of determination, the R square. Here it's close to 85%. Now really, what does that mean? Well, the coefficient of determination here is 85%. That tells us, in other words, 85% of the behavior or the differences within and among the values for our dependent variable, what is going on, I can explain, I can answer those differences when I look at the specific predictor variable or independent variable. That's what we mean by the coefficient of determination, R square. So it explains, I can explain the behavior of dependent based upon the independent variable. Very, very important to understand that concept. So in this particular situation, I'm explaining away 85% of the reason why the dependent variable changed. That simply means, of course, non-determination. 15% I can explain away utilizing, we'll say, the first grade as our independent variable. Let me come down here, looking at the bottom, and that breaks it down by our coefficient. So you have the y-intercept, you have first grade, and really what I've done here, highlighted in yellow, I've typed out really what that least square or linear expression happens to be. So what we're saying here, the final grade, that's my dependent variable, is equal to the y-intercept 18.99 plus the slope 0.74 times my first test, which is my, of course, independent variable. So that's the linear expression. Now, just by itself, I don't know if that is a good equation to use to forecast the final grade. I don't know if there is a relationship between the two variables. That is where the p-value comes into play. And it's the p-value for the coefficient or for the beta, which is 0.0004. Now, if you recall from, what was it, Chapter 2, when we went through the areas of probability, we did discuss the p-value. And the p-value, if the p-value is less than the level of significance, 5%, we know we would say there is a significance level. If p is greater than the alpha or the level of significance, there is no relationship. And this comes back to that hypothesis testing concept, whereby the null hypothesis would be there is no relationship. The alternate hypothesis would be that there is a relationship. And our so-called statement of fact would be reject the null hypothesis if p is less than the alpha or level of significance. Reject the null, no significance, no relationship if p is less than, in this case, 0.05. And you can see it is. So therefore, if we reject the null, excuse me, we are saying there is a significant relationship, in this case, this problem, between the dependent variable final grade and the independent variable, the first test grade. So this is a good equation to use to forecast. And within that problem, they wanted to know if, I believe it was from the standpoint of the first test was 83, what would one assume the final grade to be, and that would be the 80.4. So hopefully this helps once again to look at Excel, regular Excel, and to be able to identify the significance of the relationship that we have between dependent and independent variables.